I wanted to make a video to talk about multiplying and factoring algebraic expressions, and also specifically to talk about one of my favorite methods for factoring, which is sometimes called the AC method or factor by grouping. Alright, so first of all, what do we mean by factor? So let's start out with just a number. Let's say you had the instructions factor 24. Alright, so you may have some ideas here of what to do. You may know some factors of 24. So for example, we know that 1 times 24 is 24. Maybe you thought of a different combination like 2 times 12 or 3 times 8, and there are others. Can you think of a factorization? So these are factorizations, things that multiply to be that number. Can you think of a factorization that uses more than 2 numbers? How about 3 numbers? Right, so a couple different options. We could do 3 times 4 times 2. All right, so that would be 24. We could do a factorization with 4 numbers, 3 times 2 times 2 times 2. We could do one with 5 numbers, just that, with a 1. With 6 numbers, we could add an extra 1, and so forth. Now all of these use whole numbers. We didn't specify here, so maybe you want to use negative numbers. So we could do like -3 times -8. We can do fractions. We could do 48 times 1/2. So there are lots of different options, and it's kind of vague or open-ended when we say factor 24. Now a lot of times what we're interested in is what's called the prime factorization, or the factorization that uses only prime numbers in the product. So if we look through all of these different factorizations, here's the one that's prime. And remember, 1 is not a prime number since it doesn't have 2 factors. It only has itself, the number 1. So primes all have exactly 2 factors. So that one would not be a prime factorization since it has this non-prime number in there. All right, so each number has a unique prime factorization, and what we want to do for algebraic expressions, a lot of times we'll just say factor, and it's implied that we're looking for something similar to a prime factorization. In algebra, we just call it irreducible instead of prime. Okay, so here are some algebraic examples. We have a trinomial here, x squared plus 4x plus 3, and here are 2 factors that multiply to be that trinomial. So we have x plus 1 times x plus 3, right? And that is the factored form of that expression. We have another one here, and it looks like I have an error. I think I forgot to change a few numbers, but we could do 3 times x plus 1 times x plus 3, and that would be 3x squared plus 12x plus 9. And again, we call this expression on the left the factorization of this expression on the right, and in fact this one on the left turns out to be the irreducible factored version, or what's similar to a prime factorization. Alright, so in order to understand factoring, we have to first understand multiplication. So if you look back at factoring 24, you wouldn't have known what to do if you didn't know things that multiplied to equal 24. This would have been tricky to do. So similarly, we need to know how to multiply in algebra before we can factor, which is like dividing. Okay, so we've talked about FOIL before, so that's a nice acronym to remember how to multiply. So I'll review one of these, and then hopefully you remember this technique. So we would do the first terms multiplied, so 2x times 3x. And then we would do the outer terms, so 2x times -8. And then we would do the inner terms, -5 times 3x. And the last term's negative 5 times negative 8. Okay, so you would end up with 6x squared minus 16x minus 15x plus 40. And then finally you would combine the two like terms in the middle to get 6x squared minus 31x plus 40. All right, and then you would do something similar for this second problem if you want an extra one to practice. Okay, so what do we mean by factor in algebra? We mean write the expression as a product of irreducible expressions. So these are like the prime numbers for algebra. So how do we decide if something is irreducible? There are a couple things to check. We want to make sure that the greatest common factor of all terms in each expression is a 1. And then I'm going to show you one factoring rule that we can use to confirm that nothing else can be done. So we're restricting our conversation about factoring to only quadratic equations. So it's pretty easy to decide if these are irreducible. You're going to have answers that look something like maybe 2 times x plus 4 times x minus 5. So you'll have like two binomials and maybe a number out front. We might end up with just two binomials, so like 2x plus 1 times 3x minus 4. And then it's also possible that we can use this one factoring rule and decide that the quadratic expression can't be factored. So let me give you an example. Here's one that doesn't work. X squared plus 4x plus 5. All right, so this is irreducible, and we'll talk about a nice way to confirm that that can't be factored. Okay, so two quick examples of factoring out the greatest common factor, because this is part of breaking an expression down into its prime factorization or its irreducible factorization. All right, so we look for the greatest thing that can be divided evenly into all terms in the expression. So if you look at the numbers first, into 3 and 15, right, 3 goes evenly in, that's the largest thing. And then if you look at the variables x squared and x, well, you can divide both of those by x, but nothing greater than that, not like x squared, because this last term only has an x, not an x squared. All right, so 3x is the greatest common factor, and then you would write that outside of a set of parentheses, and then you want to see what's left when you factor out the 3x. So what we mean by factor it out is divide each of these terms by 3x. Right, so when you divide 3x squared by 3x, the 3's will cancel, and then the one of the x squareds in the numerator will cancel with the one in the denominator, and that leaves you with just an x. And then when you divide negative 15x by 3x, the negative 15 divided by 3 becomes 5, and the 2x's cancel out. Right? So to double check this, you would just distribute or remultiply and see if it equals the original expression. So 3x times x is 3x squared, and 3x times negative 5 is negative 15x. Okay, so that equals the original, so I know that my factorization is correct. So this part in blue is the answer, 3x times x minus 5. 4x squared plus 6x. So the greatest number that goes into both 4 and 6 is 2, and the largest variable that divides into both of those two terms is an x. Okay. So here's another way of thinking about it. You can think of dividing each of these by 2x, or you can ask yourself the question, 2x times what equals 4x squared? So that would be 2x times 2x. And then same question, 2x times what equals 6x, and that would need to be a 3. All right, and that's it. We can factor the greatest common factor out of a trinomial, out of all 3 terms. And here's one suggestion. If you see a negative at the front of the trinomial, I would factor that out as well. So the largest number that goes into -5, -15, and 20 would be 5, but then I'm also going to factor out a negative sign. Right? And then for the variables, I could take an x out of x squared and x, but I can't take an x out of just the number 20. So there is no variable that can be factored out of all three terms. So the only thing I want to factor out is a -5, and then I'll be left with x squared plus 3x minus 4. Okay. All right, and then normally what we would do is go one step further and see if this part in parentheses can be factored, right, into two binomials. So we'll do that next. Okay, and then the last one, what we want to do here is another thing to check is the greatest common factor of each expression in parentheses, is that also a 1? So is there anything that can be factored out of 4x plus 9? Well, there's no number that divides evenly into 4 and 9 other than 1, so that piece is done. But out of 8x minus 6, we could factor out a 2. So we've got 4x plus 9 times 2, and then when you factor 2 out of 8x minus 6, that becomes 4x minus 3. And then normally if you have this single number here in the middle, we would move that out to the front. So we would write the answer as 2 times 4x plus 9 times 4x minus 3. Okay, so what I'd like to do is show you one factoring method that will work every single time, and if this method doesn't work, it's an indication that the trinomial cannot be factored. Right? So we start out by writing the expression in the form ax squared plus bx plus c, and then if we were trying to factor an equation, we've just done expressions so far, but if this was equal to 0 or maybe equal to y, we could factor it as well. We also want to make sure that the greatest common factor is 1. So if there was a number that you could take out of all three terms, you would go ahead and do that. Right? And that just, it's not essential to do that. The method will still work if you don't, but it's just a lot easier rather than dealing with really large numbers. Okay, so we've got an a, b, and c in this equation, and the first step is to multiply a and c, and we're going to use this sort of like this x template, and you're going to fill in each of the 4 sections. So the first one gets whatever a times c is. In the bottom you write b, and then we're going to look for 2 numbers to go in these 2 spots. All right, so I think this will make more sense if we try it with actual numbers. So I'm going to do an example, and we'll flip back and refer to these directions. All right, so let's try 6x squared minus 31x plus 40. And this is one that we already talked about at the beginning of this video, and I showed you what binomials multiplied to be this. So we kind of already know what the answer is going to be, and that'll allow us to check and make sure it's correct. So the first thing you do, draw an x. Okay, find a and c, which are 6 and 40. Multiply them, and those would go in the top spot of the x. Right? Then next you would identify b, and that would go in the bottom spot. Okay, so remember a, b, and c are just the numbers, not the x's or the variables. Right, so I'm only putting numbers in this x. Next, I want to look for 2 numbers, and I'm calling them d and e, and we need them to multiply to equal ac and add to equal b. So I'm going to put those 2 numbers in the other 2 spots in the x, and we want them to multiply to be ac, but add to be b. Okay, so I need 2 things that multiply to be 240 and add to be negative 31. So if you already can think of what this is, maybe just trial and error or think about it for a minute or 2, if you can come up with those 2 numbers, then just put those right in these 2 spots. If you're having some trouble with it or you want an organized way to do it, here's a suggestion. I would start with 240, and then start listing out all of the possible factors. So I would start with 1 and whatever the number is as the first one, and then I would start increasing the number 1, and then this other number on the right is going to decrease. Okay, so like 2 and 120, 3 and 80, 4 and 60, 5 and 48, 6 and 40. And you might wonder how far you need to keep going. So one answer is keep going and find the right combination of numbers. The other answer is we stop when we start seeing repeats. Okay, things we've already listed. And that's going to happen when you get to the middle of the number, which is around the square root. So if you use a calculator and you find the square root of 240, it's not a whole number, but it's about 15 point something. So that tells me that I'm going to be able to stop making this list of factors when I get to 15. Okay, so I would try 7, and 7 doesn't go evenly into 240, so that can be skipped. We can try 8. Right, and 9 doesn't go evenly, so we skip it. 10 works, 10 and 24. 11 doesn't work, 12 does, 12 and 20. Okay, and I'm going to keep going to the right here. 13 doesn't work, 14 doesn't work, and, oh, maybe I can squeeze it in. How about 15 and 16? Okay, now my very next one, I would increase that 15 to 16, and then that 16 on the right is going to drop down to 15. So I see my first repeat, and from there on out, everything is going to just be one of these options I've listed, just in the reverse order. Okay, so you'll find like 17, 18, 19, etc. don't work. The next is going to be 24 and 10. All right, so we have a complete list of all of the different whole number factors of 240. And now we need to get the right ones that add up to negative 31. Right? So I need to worry about the plus or minus signs. And since 240 is positive, then the two numbers I'm multiplying need to either both be positive or both be negative. And since they've got to add up to be a negative number, negative 31, then I know they both have to be negative. So I'm going to go through and all of these should be negatives. And then I'm just looking for the two of them that add up to be negative 31. All right, so if you look, the very last one that we found is the one that works, negative 15 and negative 16. Okay, so now we have this x all filled in, so it's time to move to the next step. So next I'm going to rewrite bx, the middle term, as dx plus ex. So I'm going to rewrite it using my two new numbers that I found. All right, so I'm going to leave 6x squared and leave the last term, plus 40. And in the middle, instead of negative 31x, I'm going to write that as negative 15x minus 16x. And can you see that I haven't really changed the problem? That still equals negative 31x. But what I'm doing is sort of like a reverse FOIL, so I'm uncombining the like terms. Okay, and then the next step is to factor the greatest common factor out of these pairs of terms. So I'm going to look at 6x squared minus 15x first, and then negative 16x plus 40. All right, so there's no greatest common factor for all four of these terms, but if I just look at them in pairs, then I see that out of 6x squared minus 15x, I can factor out a 3 and also an x. And then what's left is 2x minus 5. And then I repeat that for negative 16x plus 40. So I can see I can take out an 8, and I can't take out any variables, just an 8. Now, here's the other thing you need to do. If there is a negative in this first one, okay, with the negative 16x, you also want to factor that out as well. Right? So I'm going to take out a negative 8, and then what's left is 2x and then the sign will change on the 40. That's going to become minus 5. All right, so we'll pause here, and if you do this correctly, these two parentheses should match. So once you do the first one, then you kind of know what you're looking for in the second parentheses. All right, now what I have are two big terms here. I have this whole thing and this second term. And notice that in each of those terms, they each have the parentheses 2x minus 5. So that is a common factor for the terms. And the next thing I'm going to do is factor out that whole thing, the 2x minus 5. And then what's left goes in parentheses next to it. So what's left is this 3x and this minus 8. All right, and that's it. So this is a factorization for the original expression. So this is the one that we already found when we multiplied previously. So let me flip back to it. Let's see. Okay, here we go. We saw that 2x minus 5 times 3x minus 8 was 6x squared minus 31x plus 40. Okay, and there it is. Okay, so let's try it with a simpler one. X squared plus 10x plus 16. So here's what I would do again. I would make an x, multiply a and c, and put that in the top. So 1 times 16 is 16. And then b, 10, would go in the bottom spot. Next, look for two numbers that multiply to be 16 and add to be 10. Okay, so maybe you want to think about the positives and negatives. So if they're multiplying to be positive 16, then they either need to be both positive or both negative. And since they're adding up to a positive 10, they should both be positive. Right? So maybe you can think right away of what those are. If not, make your list. So you would do 1 and 16, 2 and 8, 3 doesn't work, 4 times 4, 5, 6, 7, 8, and 2 would work, but that's a repeat. Okay? So notice the square root of 16 is 4. So in other words, I can stop my list when I get to a 4. Everything after that is just going to be the same thing. So those are our only three options, and hopefully you can see that 2 and 8 are the numbers we're looking for. Okay, they add up to 10, multiply to be 16. Okay, so next step, rewrite the expression. So we'll leave x squared and 16, but in the middle, instead of 10x, we write this as plus 2x and plus 8x. Okay, the two new numbers that we found. All right, and then factor out the greatest common factor from the first two terms. So out of x squared and 2x, we can take out an x. And what's left is x plus 2. And then out of the second two, you can take out an 8. And what's left is x plus 2. All right. In the middle here, if there is no minus sign, you would fill that in with a plus sign. And then finally, there's an x plus 2 in each of these two terms. So that can be factored out. And then what's left is x plus 8. All right, and that's the factorization. Now there's a bit of a shortcut here. If a is a 1, then your numbers in the x will just be the numbers that go in the two parentheses. So you could have just skipped over and said, okay, I know it's going to be x and x to make x squared. And then my last two numbers are plus 2 and plus 8. Okay, but that only works if a is a 1. So you can see from the previous example when a was a 6, those numbers that I found, negative 15 and negative 16, they were not the numbers that went in the last spots in the parentheses. All right, let's try another one. 3x squared minus 6x minus 24. Now the first thing you always want to do is check and make sure that the greatest common factor is factored out. So I did that on the other two. I didn't mention it, but there was no number to factor out. Here we can take a 3 out of all three terms. So let's do that first. And then what's left would be x squared minus 2x minus 8. Okay, so now I'm going to use this, this one factoring method for just the part in parentheses. All right, so I'm going to make the x. AC is now 1 times negative 8, and then B is now negative 2. So I need two numbers that multiply to be negative 8 and add to be negative 2. So since they're multiplying to be a negative, then I know that I need 1 plus and 1 minus. And since they're adding to be a negative 2, that means that the larger number has to be negative. Right? So negative 4 and positive 2 should work. All right, and then the shortcut, since this a that I was looking at was a 1, that means I can jump right to the factorization from that x. All right, so we would bring down the 3, that's still multiplied or factored out in front, and then the rest of it is going to be x, and then these two numbers that I found, plus 2, minus 4. Okay, and that one's done. Alright, so that's the gist of the AC method. I'm going to make a second video to do a few more examples and some different shortcuts you might notice as you're going through this, but that is the basic gist.